For our presentation, Bridgett Royston and I chose the article entitled Effects of Multimedia on Cognitive Load, Self-Efficacy, and Multiple Rule-Based Problem Solving. We chose this particular article because it discussed cognitive load and self-efficacy, two topics that we had learned about in class. The purpose of this article was to experiment with non-interactive and interactive multimedia and to evaluate their effectiveness on cognitive load, self-efficacy, and the learner's performance of solving multiple rule-based problems. In Scenario 1, the student is given a multiple rule-based problem to solve using non-interactive multimedia. For the example of non-interactive multimedia, we chose a PowerPoint presentation. We took the sample problem introduced in the article and created a PowerPoint out of it. As you can see, the PowerPoint does not allow you to manipulate the icons on the screen, but only flips forward to future slides. Students given this problem must either remember the steps to the problem cognitively or use pencil and paper to store the information. Test subjects were not given the option of paper and pencil. As you can see, this makes it very difficult to solve the problem because the many steps are taxing on the cognitive load. The student will often feel frustrated and therefore self-efficacy is diminished. The student may no longer feel he or she has the ability to solve such problems because his or her cognitive load was overwhelmed with many rules for the problem. Though the visual is a nice one using the PowerPoint presentation, this presentation does not offer optimum results. In Scenario 2, another student is given the same multiple rule-based problem to solve using interactive multimedia. The interactive multimedia that we chose was a smartboard presentation. The reason that we chose smartboard is because the student can manipulate the icons on the screen and actually use them to assist the student in solving the problem. The student is able to move the airplane icons to the correct terminals based on the rules given by the problem. Since the interactive multimedia allows the student to arrange the icons, the student does not have to store these problems in his or her cognitive load or on paper, but can display it on the multimedia. The student can then solve the problems very easily. With the ease of solving this and similar problems, the student develops self-efficacy and believes he or she has the ability to solve multiple rule-based problems, whereas the student who had to use paper and pencil over their memory does not. The smartboard can be incorporated into any lesson to assist the teacher's instruction. In conclusion, solving multiple rule-based problems is a complicated process made easier by interactive multimedia. Manipulative function gave the student the ability to solve the problem easier and build self-efficacy and reduce cognitive load. The fallacies of this experiment are that the experiment was only done with this particular type of problem, it was limited to a select population of mostly college students, and was very general in nature. Research in the future should include a more diverse population.